This relatively short video is designed to answer the question written above, trying to determine how much money you should put in now if you had an expected return of 8% compounded quarterly in order to have $20,000 in your account at the end of 6 years. What that means is we're trying to figure out how do we get to $20,000 if we put in a principal, which we don't know, so we'll call it P, and that increases 0.25% each quarter of a year. And since we have 6 years, we have 4 times 6, 4 times a year for 6 years, or 24 compounding periods. So if we simplify this and clean this up a little bit, we have 20,000 equals P times 1.02, that's 8% divided by 4, written as a decimal, and added to 1, to the 24th power. If we calculate this lump of 1.02 raised to the 24th power, we could write down the number 1.608437249, and there's going to be some more stuff there. That is our multiplier, the equivalent multiplier for doing 6 years at 8% compounded quarterly. So our principal is going to grow 1.60843 blah 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 to that many times what it is originally. We want that to be $20,000. So obviously what we simply need to do is divide by that amount in the parentheses. If you write down all the decimals, or if you keep nice track of it, and then simply divide 20,000 by that number, you can take that off to the side and do it. You can store that number in your calculator and bring it back, hit 20,000, divide by what you've stored. Or you can hit the 1 over x or the x to the minus 1 key when you've got this, what 1.02 to the 24th is, which is 1.6084 blah blah blah. When you hit the 1 over x or x to the minus 1 key, you have the reciprocal of it in your calculator held exactly. And then since dividing by 1.60 blah 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 is the same as multiplying by its reciprocal, that's true of any number, divide by it is like multiplying by its reciprocal, we could simply multiply 20,000 by the reciprocal. Any way you cut this, you're going to get P is approximately $12,434.43 rounded to the nearest penny, and that works if you keep track of your decimals of your numbers as accurately as possible. Sorry about that $sign, not very good. And this is the way you work this problem if the question is how much should you put in now in order to arrive at a certain amount some period of time ahead. You could do this for any kind of problem. You can make up your own problem. I'll do another quick one on the next slide. So here's a second problem, very similar to the first one, for you to pause and try yourself and then check and see what the results are. So now would be a good time to pause. However, if we're going to write this out, you should get 34,500 equals a principal times, let's erase that and clean that up, times 1 plus 0.075, don't forget the 0 in there, over 2, all raised to the 2 times 10 power, because we're doing it for 10 years semi-annually, which means twice a year. That means there's 20 compounding periods. So of course this says 34,500 equals a principal times 0.075 0.075 over 2 gives us 0.0375, so we have 1.0375 raised to the 20th. This lump right here is 2.0881519996, etc. And we simply divide both sides by that lump now. So we're going to divide by this thing in the parentheses. Divide each side by that thing in the parentheses. And that's going to give us a principal of approximately $16,521.79. Hope this has been helpful.